All right, let's go into section 12.3. Now, in the first section, we had the measures of center. Give me a single number that represents the middle of the data value, the middle data value, the center of the data. In this section, another component of a set of data that we're always interested in is how spread out the data values are, or how dispersed they are. So these would be measures of dispersion or spread. Is there big spread in the data values or a small spread? Are they all kind of clumped together, a homogeneous group, or are they spread out widely? And the first one is one that we've already calculated, and that's the range. If you want to know how far data values are dispersed, their range, just take the highest data value that we call the maximum or the max, and subtract the smallest data value that we call the min. All right, and then we're going to be calculating the standard deviation. Now, the standard deviation is like an average as well. It's just not averaging the data values. It's averaging instead the deviations from the mean. And so let me show you with a small data set what all of this means. The mean is X bar, and the data item or the data value is X. So the first thing we're going to do is we're going to take each data value and we're going to subtract the mean. Then this says we're going to take that X minus X bar and we're going to square it. Later on, we're going to take the square root, as you can see down at the bottom. So we'll undo that square by taking the square root. Once we get all these guys, we're then going to sum them all together. So we're going to call this the deviation from the mean, and this the squared deviation from the mean, and then we're going to sum up all those squared deviations from the mean. By the way, the standard deviation that we're after is Sx from the calculator. All right, next, we're going to take the sum of those squared deviations and divide by n minus 1. N minus 1 is 1 less than the sample size. And then finally, we're going to take all of that and take the square root. So there it is. All right, let's take a look at an example. All right, so here's some here. All right, so the standard deviation is a measure of the dispersion, the spread in the data. And so which of these two data sets, 30 or 32? If you calculated the standard deviation in each case, which one would have the larger standard deviation? Before we even calculate it, I just want to give you kind of a conceptual idea of what the standard deviation does for us. So let me ask it again. So your answers are number 30 or number 32. Which one of these two data sets have the larger standard deviation? 30? 32. No answers yet. 8, 9, and 10. In this data set, we've got the data value 8, the data value 9, and the data value 10. And the frequency is 2, 3, and 2. 2, 3, and 2. 8. So this is n is equal to 7. Well, let me just say again, the standard deviation is a number that describes the spread in the data. If the data are more spread out, the standard deviation will be higher. If the data are all clumped together, the standard deviation will be smaller. which of these two graphs have a larger standard deviation, 30 or 32? Another way to say that is which data is more spread out? What set of data is more spread out? Okay, we're short on time, so I'm just going to say, Amanda, you are correct, and it is 32. These data values are spread out between 6 and 12, whereas these data values are only spread out between 8 and 10. So close together and spread out. The data set that's more spread out will have the higher standard deviation. All right, so this data set here is 8, 8, 9, 9, 9, 10, and 10. So those are our data values. I want to show you how to calculate the standard deviation if you have a set of data like this. The first thing we have to do is to calculate the mean. So what we're going to do is we're going to add up all those data values, 8 plus 8 plus 9 plus 9 plus 9 plus 10 plus 10, and divide by 7. So the mean is equal to 9. Sum of all the data values divided by the number of data values, 7. Here's what I'm going to build. I'm going to build this formula for the standard deviation. It's the sum of the data the squared deviations from the mean divided by n minus 1, all under a square root. So I'm going to have 2 additional columns. I'm going to have x minus x bar, which is the data value here, minus 9, because we know what x bar is. The next column, I'm going to take all the numbers in the previous column and square them to get the squared deviations, because that's what appears right here. So this is how it works. We take the data value 8 and subtract 9. We're going to be subtracting 9 from all of these data values. That's -1. Same thing here, -1. All of these data values where we have 9 minus the mean 9, we're going to get 0. And if we have 10 minus 9, we're going to get 1. All right, in the next column, we're going to square the deviations that we have in the second column here. So since -1 is the number here, we're going to square that and get 1. -1 squared, 1. 0 squared, 0 squared, 0 squared, these are all 0. And then 1 squared and 1 squared, you get 1. Now, if I take all of these numbers and add them together to get the sum, in math symbols, this is the character for sum. What are we summing together? We're summing together all of these squared deviations. So we want to sum up all these numbers in this column. 1 plus 1 plus 1 plus 1 is 4. So up here, we're going to have the square root of. The sum of this whole top number here is the sum of this last column. So that's where the 4 is going to be. And then our value of n, 1, 2, 3, 4, 5, 6, 7, n is equal to 7. So we put 7 in there for n, and then subtract 1. So this is the square root of 4 over 6. And let me just go ahead and calculate that. 0.8165, we'll call it. All right, let me show you what we just did. This here is the standard deviation. So it says, use each display of data items to find the standard deviation. So Sx is the standard deviation. There's this very complicated formula and I just showed you how to use it up here. But the number that we end up with, that number is the standard deviation. Now, we didn't calculate the standard deviation of this one, but what we did say is that the standard deviation of this one over here is going to be larger than the standard deviation of this one because these data values are clumped together and these are spread out. All right, the next thing I'm going to do is I'm actually going to enter in the data values into a list and have the calculator calculate it for us. All right, so in list 1, I'm going to enter in these 7 data values. Won't take long. 8, 8, 9, 9, 9, 10, 10. So there they are, our 7 data values in list 1. All right, then I'm going to quit to go back to the home screen. And then the steps are, okay, stat, where we would enter data, we go over 1 to the calculate menu and then select number 1. And the X list is L1. That should already be set up for you. The frequency is blank because there's no frequency list. And then we calculate. And what I want you to focus in on is this number right here. You see that number? Have you seen that number before? I'll put them side by side. So that standard deviation that we calculated by hand, there it is. So in this section where you're doing problems in section 12.3 and they ask you for the standard deviation, you can actually just use your calculator and calculate that instead of using the long format. I should caution you as well that if you ask for help in my math lab, they're going to take you through this long process here. So write yourself a note that, you know, we'll rely on the calculator. This is how fast it is. Here's this data set. We have 3 6s, 6, 6, 6, 3 of those. 9, we have 1 of them. And then 12, we have 3 of them. Now, the calculator will give us the mean, will give us the median, will not give us the mode. But let's type in those 7 data values there. I'm going to type them right on top of these. 6, 6, 6, 9, 12, 12, and 12. We'll get them all on the screen at one time. 6, 6, 6, 9, 12, 12, 12. All right, then I'm going to quit. Go back to the home screen. Stat, calculate, 1 variable statistics, L1, and then there's the mean. And there's the standard deviation. And the median, well, you can see the middle data value is also 9. But what I want to draw your attention to are these 2 numbers. 3 is much larger than 0.816. Since 3 is larger than 0.816, this data set is going to be more widely dispersed, spread out than this data set. Okay, so that's pretty much it. The mean, median, mode, mid-range, measures of center, and then calculating the standard deviation. We did it by hand, and I would prefer that you use the calculator. So we'll be practicing with larger data sets soon.